Okay, so hello everyone. This is a part 2 of the Hess Law that I've done in the previous video. If you guys can remember, we only used 2 equations to come up with the final equation. This one, with the final desired equation. In this case, we'll be using 3 equations. So our desired equation for this one is NO plus O. That NO plus O will yield NO2. Now we have 3 equations here. So let's start. Okay. So for the first equation, we have NO plus O3 yields NO2 plus O2. Now, if we look at the other equations, the equation number 1 is the only one that contains NO, and the rest there's no NO present. So in this case, we'll let step 1 be as is. Let equation 1 be as is. So step 1, this is as is. Next. Okay. I'm sorry. Next is we have O3 will yield 3 halves O2. Now in this case, in order for O3 to be cancelled, we need to reverse this equation so that the O3 on the second equation will be placed from the reactant side to the product side. So meaning, step 2 is reverse. Now, remember, the moment that we reverse our equation, the enthalpy value will change. In this case, H2 is negative. After reversing it, from negative, it will become into a positive H2. Next is we have step 3. Okay. Now in step 3 is we have O2 will yield 2 oxygen. Now in this case, since in the desired equation we have oxygen, and that in the third equation O is placed at the product side. Now we want it to be at the reactant side. So what we're gonna do is we're gonna use multi-steps or many steps in this case, or just 2 steps. Now, by the way, in future Hess Law equations that you guys might encounter, you can use multiple steps. Again, you can use multiple steps in one equation. You can reverse, and then you can divide, reverse, multiply. You can do that. You're free to do it. So in this case, we're gonna reverse the equation. We're gonna reverse the equation. And now, the desired equation only contains 1 mole of oxygen gas. In this case, we're going to divide it into 2. So, we're going to use 2 steps, which is reverse and divided by 2. Now, for the sum of the enthalpy, or the enthalpy for the reaction, the equation that we're going to use is, since this is as is, the H1 value remains negative. So, negative H1. Step 2 is reverse. So in this case, we're going to change negative into positive. Meaning, from negative 142.3 kilojoules, it becomes 142.3 kilojoules. So, it's positive H2. And lastly is we have the reverse of the equation. I'm sorry. So in this case, it's 495.0 kilojoules. Again, we're going to reverse the third equation, and we're going to divide. So meaning that the enthalpy for H3, instead that it remains as is, or 495.0 kilojoules, we're gonna change the sign and divide it by 2. So in this case, it's gonna be negative H3 divided by 2. Okay, I hope you get it, guys. Now we're gonna use the steps so we can visually illustrate it. So anyways, I'm sorry. Okay. So first step is as is. So we'll let the first equation remain as is. So just copy. Next step is we're gonna reverse the equation. So the oxygen gas will be placed at the reaction side, and the O3 will be placed at the product side. Lastly is we have reverse and divided by 2. So Since in this case we're gonna reverse, meaning that 2O will be placed at the product side, I mean at the reactant side, and O2 is placed at the product side. So this is the reverse equation. Now we want the 2 to be cancelled, so we're gonna divide both sides by 2. So the remaining compound, or the remaining molecules, or the remaining elements that we have is O will yield 1/2 O2. 1/2 O2. So this is it. Pansit. Okay. Again, we reverse the equation. In this case, O2, in this first equation, in the third equation, the original third equation, O2 is at the left side, and at the left side. In this case, O2 is at the right side, at the product side. In this case, 2O is at the right side, and this one, 2O is at the left side. At the same time, we divided it by 2 to cancel 2. So we have O will yield 1/2 O2. I hope you get it. So let's solve for H. First, let's cancel it so that we can visualize until we can reach this final desired equation. Okay. So O3 is cancelled. And O2, since we have... Okay, guys. Like I've said earlier, we can cancel out the oxygen gas. Okay? So how are we going to do that? In this case, we have 1 mole of oxygen gas, so that's 1 minus... Oh, I'm sorry. We have 3 halves of oxygen gas. And we're gonna subtract these 2. Since they're at the right side, meaning they can be combined. So, this is understood to be 1 plus 1/2. So, okay. Alright. So this is it. That's it. So for final this one. Wait, I hope I got it right. For a while. 1 plus 1/2. Okay, we have 3 halves. I'm sorry, it's up 1. Now, if we subtract it again... Okay, we got 0. Okay, the reason why we got 3 halves in the first place is because we combined these 2 to subtract this one. Since they are the same, they are common. So, yeah, it's understood. Now, in this case, O2 is not cancelled, but it's reduced. Oh, O2 is cancelled. I'm sorry. O2 is cancelled, my friends. And now we've reached our final destination. This is NO. We're done with NO. Plus... Oh, this also cancels out. I'm sorry. Plus O. Don't forget the O. MB and O2. Now we've reached to our final destination. Our final equation. Now we're gonna solve for the enthalpy. Since that's the most important part of Hess Law. I'm sorry. So in this case, we're gonna calculate this one. Negative H1, so it's negative 198.9 kilojoules plus 142.3 kilojoules. Remember, it's reversed, so from negative it became positive. Okay? Minus 495.0 divided by 2. Oh my god. My equation is very... this one. So, using our calculator, guys, negative 198.9 plus 142.3 minus 495.0 divided by 2. We get a final answer of negative... So, our final H is negative 304.1 kilojoules. Okay. So, in this case, let's check the significant figures again. All of the given equations, all of the given units have the same decimal places, so there's no least or there's no greater decimal places. So we're just gonna copy everything. In this case, we have each of the h has 4 decimal places, so the final answer must be 4. And always remember that the units for Hess Law is kilojoules for enthalpy. Okay? Thank you guys.